As you get more into your tech journey, it's not just going to be about, web development and, the MERN stack. We're using Mongo, Express, React, Node. It's going to get a lot more complex, a lot more, building real world enterprise level applications. It's going to be a lot more technology. And that's why one of the reasons that on this channel, we go into the DevOps side of things. We go into understanding different types of infrastructure and technology. We go into infrastructure as code. We're working on the large language models as well to get more familiar with AI and prompt engineering. But everything is connected to one another. And as you so let's say you're trying to get into this tech space, you're not going to be landing a position at a company who needs just a someone who just graduated a boot camp knowing how to do Mongo and Express and stuff like that. You're going to need to know that, but it's not going to be at that limitation. So today I want to talk about messaging brokers and something that I really want to learn more about. I've been around this technology since probably 2017 to 2018, and the company that I work for now, this is a big part of our company. Um, and I wanted to get a lot more familiar with it. You might have heard of some tools like RabbitMQ, Amazon SQS, Amazon MQ, and other providers like that. But it is about messaging. It is about messaging brokers. So we're going to be talking about messaging brokers, right? So with that being said, let's jump into it to figure out more about how these messaging brokers work, what's their purpose, and who uses them, and how we can get a lot more familiar with them. Because guess what? Like I was saying earlier, if you think you're just going to learn what the bootcamp taught you and then that's it, you are in for a very, very rude awakening. So you want to start getting more familiar with this technology now so that once you get into that company, you're like, okay, this makes sense. You want to also be able to start practicing with it, find a way to implement it on something that you're doing, because and not just going to be, oh, I'm going to do an API that interacts directly with the database. When you're working on large scale software, things that are coming back and forth all the time, you need a better way to do it. And through the messaging brokers, that might be that way to do it. All right. So let's jump into it. So we're going to be talking about messaging brokers. Let's jump into our agenda. So we're going to go through an introduction, the key concepts of messaging brokers, the purpose of them, who uses them and why, some popular tools slash apps that manage your messages. We're going to talk about the architecture overview of it, and we're going to look at some real world use cases. And then I threw in, so we have the benefits and the challenges, and then I threw in an example comparing to like using the term broker that we know from other industries and see how can we use that as an analogy to how can we use that as an analogy to this messaging broker to get a better understanding, and then we're going to wrap it up with our conclusion. All right. So with that being said, let's jump in. Let's get started. So in our introduction, we're going to talk about what is a messaging broker, the role of a messaging broker in modern software architectures, why it's important to have a messaging broker in distributed systems and microservices. We just spoke about microservices a couple of months ago. So, what is a messaging broker? A messaging broker is like a middleman that helps different programs talk to each other by passing messages back and forth. So, it's the middleman. We give the message that we want to send to the middleman, and the middleman is going to take that to whoever's supposed to receive it, and back and forth, right? It makes sure the messages are delivered correctly, even if the program sending or receiving them aren't ready at the same time. So it says it for itself, but the whatever you're using to send messages or receive messages, they don't have to be on the same page in order for the message broker to deliver it correctly. They have timestamps and orders that they're supposed to deliver in, which you can build out, figure out, configure. So what is the role of messaging brokers in software development and in software in general? So messaging brokers are crucial in modern software architecture because they make systems more scalable, reliable, and flexible. They help different parts of an application communicate efficiently, even when those parts are running on separate servers, written in different programming languages are at line or at yeah, my goodness, or are online at different times. So basically, here's a way to understand it, right? Let's say you have a software that sends a message to another software, but there's a messaging broker in the middle, right? So the messaging broker would hold on to that message until the application that is supposed to receive it comes online, and then it can deliver there. So it's like it's a queue, it's a queue. It's holding it until available for delivery. Kind of like when you say that you're out of town with the post office and they hold your mail for a certain amount of time. So why are messaging brokers important in microservices? And we just like in our Urban Dictionary of Economic Data, we implemented a microservice for the backend and the front end, and even for the database. So the question is, would we be able to implement a messaging broker to help that application? I mean, keep in mind it's a very, very small application, but the importance is it enables services to work independently but cooperatively. It handles communication and ensures messages are delivered reliably. So it supports scaling and resilience, which are critical for complex and modern applications, right? So keep in mind with microservices, you'll have an API running here. You'll have a front end running here. You might have a different API for user management. You might have so many different components that they're working together through the use of APIs. But as the messages are being sent back and forth, you don't want to lose any messages. Then you probably want to install or set up a messaging broker to intercept all the different transactions that are being sent back and forth. So we're going to talk about some key concepts of the messaging brokers. We're going to talk about producers and consumers, queues and topics, message delivery and models, and then persistence and durability. All right, so let's get to it. So for the key concepts for producers and consumers, very, very basic. We're not going to go too in depth into this because this is very, very preliminary, high level. But producers send messages and consumers retrieve and process them. So if you think about when we're reviewing our producer price index or our consumer price index, the producers, and just in general, right? Producers are the ones who send items, send products to the store. So think about the store as your messaging broker, right? Like let's say Walmart, Target, Amazon. Let's say those are your messaging brokers, right? And the producers send items, messages to the large retail store. Consumers retrieve those items and process them. So now let's say you go over to Walmart or Target or wherever, and you purchase the item, quote unquote, the message that the producer has sent to the large store. And now that you have it and now you actually use it, you process it. So that's a very general, high level concept of the producer and the consumer. Because guess what? The producer could send you the item directly, but it's a lot more overhead and work for the producer to send individual items to each consumer, when they can just send all these different messages to the messaging broker. Now, the other thing is that what if the producer sends you something, but there's no one available to sign for it? There's no one available to sign for it. So that way it offloads that work onto the messaging broker to handle its light work, right? So another key concept is queues and topics. What is a queue? A queue, point-to-point messaging, one consumer per message. So another example, think about it as you are like the producer of canned green beans for Walmart. So one can of green beans can be consumed by one consumer. So that's a point-to-point messaging. One consumer per message, right? However, we have a topic, publish, subscribe model. broadcast to multiple subscribers. I'll give you an example right here on YouTube. So you can broadcast a live stream, a pre-recorded content where it's one video, one live stream, but it's being sent to multiple people, multiple broadcasters, whoever tunes in, right? It's not like one video belongs to one person as if you're doing a video call with somebody one-to-one, maybe a FaceTime call one-to-one. But think about like online, like, whether you're streaming on Twitch, YouTube, Rumble, X, wherever, right? It's one message that is being consumed by a multitude of people. So you can think about the topic like that. Or if you're thinking about, like, let's say Amazon Prime or Netflix subscription, right? You can have one video and you have many people being subscribed to, let's say you favorite a new TV show, right? You have one video, one broadcast, and multiple subscribers being able to consume it. Okay, so the message delivery models, at least, so 3 different delivery models. You have at least once, at most once, and exactly once delivery. And last, we have persistence and durability, the key concept, right? So messages can be stored to ensure delivery even if systems fail. So a concept of this is, let's say, so the messaging broker would have a retry policy. So if you ever notice with like USPS, so let's take USPS. You order something and the item is sent to USPS for delivery. Now they tried to deliver, and it required signature, but nobody was home. So they left you a note at the door saying, "Hey, we tried to deliver this item, but no one was here. We're going to try to deliver again tomorrow. And if we try again tomorrow, and you're not available, then you're going to have to pick it up." All right. So USPS serves as that messaging broker because of their persistence and durability, where they can retry, while it would cost the producer a lot more money if they had to continue retrying over and over and over. They might have to get their own drivers, they might have to get their own delivery people, and they'll be wasting so much time and money. But by offloading it to their message broker, in this case USPS, then it saves the producer money, and trying to reattempt delivery of that quote unquote package is just part of the day-to-day operation. So you can configure different retry logic inside of your messaging broker tool. So let's move on to the purpose and the purpose of messaging brokers, right? So decoupling systems, that's probably one of the biggest things. It allows services to interact without direct dependency. So your API does not have to be dependent on your front end. And honestly, your depending on the type of application that you're building, your API doesn't have to be directly dependent on your backend as well, on your database as well. So if the messages are being sent to different messaging brokers, and once the system becomes ready, then it can process, that system will consume those messages and process it. So it's like you can have an application running, although it's not having, like, all the other necessary components of it aren't running as well. Next thing is scalability. It enables systems to handle large volume of messages and traffic. And I'm telling you, I've seen some messaging brokers queues that have 6,000 messages in there waiting to be processed. And then it can process it fairly quickly because so now it gets queued up, and now how the application is actually processing it, the consumer is taking it in, all of that good stuff, right? Next up, reliability. Ensures messages are not lost in transmission. So it is possible that, let's say, a little glitch happens when you send a message and then it doesn't show up. So sending it to the messaging broker helps it to, like, all right, if this does, like, if for some reason something got disconnected, it didn't go through, well, we know that it didn't go through, and now we're going to retry it again. And that's the messaging broker taking care of that, right? Asynchronous communication. Enable services to operate independently and avoid blocking. So, and that's one of the goals that you want to decouple your applications as much as possible, so that they can work independently of one another, that they can not be reliant, saying, all right, if this one part is up, nothing is up. We can't have that. And that's why we move away from monolith applications. That's why we move towards microservices. But now, taking it one step ahead, the interactions that happen in between the different applications in a microservice, the messaging broker is going to help that part so we can be fully independent of one another. And lastly, we have task distribution. Distribute work across multiple workers for load balancing. So with the messaging brokers, you can have many different instances of them running, and like, let's say you get an influx of like 5,000 messages, then you can have a scaling property or principle that says, if we get over 250 or 2.5 thousand messages in the queue, let me add another queue to help process that, or to take some on themselves and help process it. Right, so next up, who uses these messaging brokers? So we're going to go through the different industries. So e-commerce uses it for order processing, inventory, and inventory updates. Okay, so let's say as an item is purchased, there's going to be a message sent from the producer saying, "Hey, this order was just done, and now whatever is processing the order is going to consume it, and then also we need to deduct the amount of inventory from our backend, from our e-commerce platform, but it might not happen right away because let's say for whatever happens in between, you can end up losing that inventory update, but the messaging broker is going to queue it and wait until it has a successful acceptance of that update, right?" Financial services use them, such as transaction processing, fraud detection, and we're going to have a financial example towards the end. Healthcare uses it, data sharing between systems. All right. So, and I'll tell you this: the other day, I saw someone making a call to share medical records with a different doctor, and they use this website where you enter the doctor's name, and it's going to generate you a code where the doctor can log in to see all your charts, history, and stuff like that. Which I'm like, wow, that is pretty cool. But I'm pretty sure, but what has to happen is after you submit the request, it's probably going to a message broker to process it as it comes in, it goes out, things like that. So based on how many people are trying to send messages at the time, it might take a little bit longer, it might go faster, so it just depends. What are the roles used in, like, who uses the messaging brokers in like their roles, right? So software engineers, they use it to build scalable applications. Like I was saying, you might want to put a messaging broker in between different parts of your application so that they can consume a large amount of traffic and then process it as time permits. DevOps engineers use it for system reliability and messaging processing pipelines. Exactly. So in order to have things move on in the pipeline, they'll be setting up different messaging broker queues. Data engineers use it for LTL processes and asynchronous data workflows, right? So that way they can run things in the background, all of that good stuff. So let's talk about some popular messaging brokers, right? So we have RabbitMQ, which is lightweight and open source. We're probably going to try installing that one at some point. Flexible routing and supports both queues and topics. And I'm pretty sure there's an Amazon MQ that's coming out. So we're going to definitely look into that too, because that one is not necessarily open source, but it should be using the same principles and protocols of RabbitMQ. We have Amazon SQS, fully managed and scalable, simple API for reliable queuing. We have Azure Service Bus, enterprise-grade messaging with advanced features. We have ActiveMQ, open source with support for multiple protocols. And we have IBM MQ, focused on enterprise reliability and security. Let's talk about some use cases for messaging brokers, right? So we have e-commerce applications processing customer orders and payment transactions. We have microservice communication. We're just talking about that, ensuring reliable data flow between services. We have task queues, background processing for jobs like email sending or image processing. I'll give you an example with the image processing, right? When you're using, like, if you're familiar with Midjourney for AI image generation, you will submit like the description of the image you want generated, right? And then it's going to go into a queue, and there's different queues based on the the level that you have, the tier that you have, your subscription. And you might, in the fast queue, it's going to take maybe a few seconds, maybe 30 seconds in order to process that image and generate it for you. So it's like doing things in the background. It's not like you're just like, as soon as you submit it, now it just automatically starts to create it. No, it goes through a queue based on the application that you're using, right? So image processing, sending email, things like that. And then we have Internet of Things application, managing data flows from millions of devices. So think about when you're using tools like devices like Alexa, your what do they call it, Apple Home. I'm not even sure what, like, but let's say your cell phone, thing like that. And you're making requests to it. It's managing that data flow from millions of different devices, right? And then real-time applications like chat apps, notifications, or live dashboards, in order to so these updates can happen. It's let's take WhatsApp for example, right? When you send a message to WhatsApp, I suppose I'm not 100% sure on this, but I suppose based on the influx of messages that's happening, although you see it right away, it's probably being sent to a queue because guess what? Guess what? What if the phone that you're sending it to, it's off? So now you'll see, like, if you never notice on tools like WhatsApp, you'll see one check mark to show that the message was sent, and then now when the person turns on their phone, you'll get another check mark to show that the message was actually delivered. So that's the difference between the two. And then you'll even see like it turns blue if they have that setting where now the person has actually read your message, right? So, but that is messaging brokers that should be, that's my assumption based on how it works, that it'll be messaging brokers happening in the background. So what's the high level architecture for messaging brokers, right? So we have the producer, which sends the message to the broker. Then we have the actual messaging broker. It routes and stores the messages, and it supports acknowledgements and retries. So what we were talking about earlier. So it stores the messages, and then once the consumer becomes available, it's going to deliver that message to the consumer, which the consumer retrieves messages from the broker for processing. So what are the benefits of using a messaging broker, right? So it decouples, which means separates the application from the components. One thing that used to be a problem back, and which is a problem in bad software development, is when software is tightly coupled, right? So you have your front end being highly reliant on your back end, and your back end being highly reliant on your database and whatever happens in between. So the messaging broker, as we said earlier, it stands as the middleman. So the two of them don't have to be tightly intertwined. So you can have a front end written in Node and using the MERN stack, and then you can have a back end written in Java or in Python, whatever the case may be, right? So and you can have whatever data. You can have a SQL database. You can have a serverless, not serverless. You can have a NoSQL database, whatever it is that you want. It improves the reliability and fault tolerance. So if for some reason your database is down or your API is down, it doesn't mean that the messages won't get delivered, because now it tries to deliver it and sees, oh, it's down. Based on the different policies that you have, once it comes back up, they should be able to consume it, right? So instead of necessarily having the messaging broker having a push, you can always have the consumer to have a pull. So, oh, I'm up. Let me check if there's any new messages that are waiting for me, right? And then scales horizontally with increased workloads. So this is like about the load balancing. Let's say you get an influx of like 5,000 messages when you normally get like 1,000. Well, it's going to need to add some more messaging brokers to be able to process those messages. So it's going to distribute that, and it's going to process it as needed. But with benefits, there are also challenges, right? So one of the challenges is managing message duplication and ordering. So especially when they're scaling. And another problem that we used to see is, from my understanding, by default, there might not be a like, as messages come in, messages get sent out, right? But ordering of the messages is very important, because you don't want to be getting random messages. Something in the software that I use for streaming, right? Before a live stream starts, people can start putting comments in the chat. But when I start the live stream on the software and the messages come through into the software, sometimes they're at different orders, which makes me wonder, are they using some type of messaging brokers inside of the application that I use to stream? Which that's the beauty of it, though. That's the beauty of it, though, because now as we learn about this, we start thinking about in all these other different circumstances that messaging brokers can be used, and that gives us more opportunity to investigate, right? Lastly, so we have overhead of monitoring and maintaining broker health. That is a huge challenge because there can be so many different brokers for so many different applications, and you need to set up different dashboards, different alerts in place. Because if one messaging broker goes down, then Houston, you may have a problem. Lastly, latency concerns in some use cases. Basically, the amount of time that it takes between the messaging broker actually being able to deliver the messages, or like from either the producer to the messaging broker, or the messaging broker to the consumer. So some challenges like with everything in life. So I want to use the stock market analogy to give us another viewpoint about the messaging broker, right? So imagine a stock trading environment where investors place buy and sell orders through a stockbroker. The broker acts as the intermediary between the investors and the stock market, right? Because if you're familiar with the stock market, this might resonate even more. Similarly, a messaging broker facilitates communication between producers, message senders, and consumers, message receivers in software systems, right? So that is a breakdown of how you can relate the messaging broker to the stockbroker. So the investor places an order to buy or sell stocks. So with our messaging analogy, a producer sends a message, for example, order details, to the broker. Now, the role of the stock messaging broker: the broker processes and routes the order to the correct stock exchange or matches it with with an existing order. For our messaging analogy, the broker receives messages from the producer, processes them, and forwards them to the appropriate consumer or consumers. Now, the stock exchange would be the queue, or the consumer, right? So the exchange matches the buy and sell orders to execute trades. Messaging analogy: a queue holds orders for the consumer services to process, ensuring the right service receives the appropriate message. So how does this actually work, right? So the producer sends a message. Investor submits a stock buy order: buy 100 shares of XYZ at $50 each. In software terms, this is like an application publishing a message to the broker. The broker routes the message. The stockbroker evaluates the order and sends it to the right stock exchange for execution. In software terms, the messaging broker routes the message to the correct queue or topic based on predefined rules. Now, the consumer processes the message. The stock exchange receives the order, matches it with a seller, and executes the trade. In software terms, a consumer application retrieves the message from the queue and processes it, for example, update inventory or send a notification. So here are some features of the broker, right? It is asynchronous communication. The investor doesn't need to wait for the trade to complete before moving on to other activities to better things with their life, maybe other trades. The messaging broker decouple systems, allowing producers and consumers to work independently. So same way as the investor places their order and they move on with their life, so does the producer sends it to the messaging broker and then moves on with his life. The consumer waits until something is ready and then it gets delivered to them. So they work independently. They're not dependent upon one another. Another feature is the message persistence. Orders are retained until processed, ensuring reliability even if the stock exchange system temporarily fails. Think about if you were to place a order before the market opens, right? So now by the time the market opens, because the system is down, by the time it opens, it's going to send that order and then process it. Messaging brokers persist messages in queues until consumers successfully process them, right? So that's the whole retry technology. It also has a high volume handling. So during market hours, a stockbroker handles thousands of trades simultaneously. Messaging brokers like RabbitMQ or Kafka are designed to handle high throughput efficiently. And I think RabbitMQ is probably the most popular one. So that is everything. Hopefully that analogy helped clarify things a little bit. In conclusion, we went through our introduction. What is the messaging broker? Why it's important? Its purpose. We talk about some key concepts of the messaging broker. Who uses the messaging broker and why is it used? We spoke about some popular apps. Probably like RabbitMQ is the most popular one. We had a high level overview of the architecture. We used some real world examples. We looked at the benefits and the challenges, and then we also wrapped it up with looking at a example analogy compared to the stock market. So Let me know your thoughts. Drop me a comment if you found this helpful and informative. Have you actually used messaging brokers? If so, which one? Have you used RabbitMQ? Have you used Amazon MQ? Have you used Amazon SQS? What was I forgot the name of the other one, right? But have you used the messaging broker software? So we're gonna go back to full screen. We're gonna wrap this up for today. Let me know your thoughts. Let me know your thoughts on this whole messaging broker. What I'm going to do is I'm going to try to set up a live stream where we can actually try to implement this in some application. I don't know. I'm going to have to find some type of example that we can use to get a better understanding, because you guys know we can go through this theory and the concept, but until we actually get hands-on, it means absolutely nothing. We have a better understanding, but we need to actually set something up. We need to see an application send a message as a producer, and then another application consumes it. Even if we're using our own applications, our own microservices to do it, maybe we'll see if we can do anything with the Urban Dictionary of Economic Data and see what we can do. All right. But that's it for today. Thank you guys so much for tuning in. I really, really appreciate it. Do me a big favor if you haven't done so already. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content, as well as go to techcoachdrive.dev. You can sign up for one-on-one coaching. You can sign up for exclusive information. See how we run it up. But that's about it for today. Remember, check out the Victory album. It's in all streaming platforms. You just search for Tech Coach Ralph Victory. You're going to see it. And remember, we're doing penetration testing starting mid-January. We're also doing large language models in the morning live streams. All of that good stuff. All right. DevOps on Sundays. Tune in and let's have some fun. Let's learn together. Let's run it up. And until next time, this is Tech Coach Ralph. We are out.
We slanging massive code. We slanging massive code. We slanging massive code. Learned the code while the city slept tight. Now I'm slinging lines that spark like late night. From Python webs to TypeScript skies. React in my veins and APIs that rise. Keyboard clacking, I'm stacking gold. Syntax flows like stories untold. Drinking caffeine, I'm breathing in cold from morning dawn till the night unfolds.
My code goes long, my code goes deep. Caught in the stream where the data don't sleep. Need my digits, better call my line. Slanging massive code like a story time.
In the hustle jungle where the bites meet still. Digital canvas where I paint and fill. JavaScript whispers in the code I weave. Tech dreams blossom in the lines I conceive. Lines so slick they can't be caught. Variables twist in every plot. Python powers every thought. JavaScript legit, hitting the right spot. My code goes long,
my code goes deep. Caught in the stream where the data don't sleep. Need my digits, better call my line. Slinging massive code like a story time.
Stacks on stacks build my empire tall. Debugging dreams where the errors fall. Lines of brilliance break the darkest night. Script so dope you can see me in the light. TypeScript magic on my fingertips. Reacts to canvas where logic flips. API dances syncing clips. My code's a song where data drips.
My code goes long, my code goes deep. Caught in the stream where the data don't sleep. Need my digits, better call my line. Slanging massive code like a story time.
We're slinging massive